Okay, guys, reflections. Day 2, not like personal reflections, but reflections of graphs. You can reflect personally if you want, but reflections of graphs. So in the past, you have reflected parabolas. So what you did is you threw a negative in front of the whole thing, and or you had a negative set pattern, or you have A was negative, and it reflected vertically. So what we call that was a reflection in the x-axis. So here's your x-axis here. And you took your parabola and you flipped it upside down. What we're going to do is we're going to do a lot more of that today. And you can do it with more than just parabolas. You can do it with your root x also. So if you throw a negative in front of that whole thing, it will reflect down. And you can do that also with our old friend 1 over x here. And let's see what happens if I do this. Oop, what just happened there? Make that negative, and that will also reflect. So I go back. Let's look at that one again. So I had it, and I flip it in green. Nope, nope, not that one. Similar, but not that one. That one there, and it flips that way. Okay, so it comes down and it reflects. It reflects downward. Okay, so that's a horizontal, a reflection in the y-axis. Now, x-axis, sorry. Let's talk about y-axis. And a y-axis would be a horizontal axis. So remember, this is your function, x squared. And before I said anything vertical is on the function. Anything that is horizontal is on the x. So I want to put a negative on the x. I'm going to have to throw a bracket in here. So if I throw a bracket in here, and, oh, not that many brackets. What's going on here? So if I go bracket, oh, man, what's going on here? Let's get rid of this. Let's start again. Sometimes it's just better to start again. If I go bracket, x, close that bracket, and square it, and now I throw out a negative. I don't like that color. Are we stuck with purple? I think we are. Okay, so throw a negative in front of the x. What's going to happen is nothing. And that's not really true. What's happened is it's flipped horizontally, so it's moved from here to here. And that's hard to see with our parabola, but it's not hard to see with our root x. So I throw an x here, notice that it flips in the y-axis or reflected in the y-axis over. So there's more to it than this, obviously. I'm not just going to say the parabolas don't flip. They do flip, but we're only going to see that when we move the vertex in the first place. So if I go ahead and I take a parabola, and I'll turn this one off for a second, and I take my parabola and I do something like this, and this goes back from yesterday. If I move it left 3, and let's move it down 1, okay, so I have left 3, it's a 3 here, but it's horizontal, so change the sign, and this means down 1. And before, what we had done in the past is we flipped this vertically. So I go ahead and I flip it from here, and I reflect it, and it moves like that, okay? So it's started there, and when I put a negative in front of it, it flips downward. That's not exactly right, but close enough. Anyway, if I throw a negative here in front, right on the x, what's going to happen? It's going to flip horizontally. So I take this guy here, this parabola here, and I have a mirror on the y-axis here, and I flip it horizontally and bring it over there. So if the negative is on the x, it goes here. It flips it that way, horizontally. Now I said that wasn't exactly right when I threw a negative here, because if I put a negative on the entire function, what I'm doing is I'm putting a negative in front of all of this. So if that's the case, what I really want to do is throw a negative in front of this entire thing. And if that's the case, you notice it looks a little bit different when you flip it. It flips and moves the, so I don't know, go back to that for a second. Here was my original, okay? And now when I throw a negative, it flips it, and the vertex is also flipped, so it's reflected that way. So what's ended up happening here is, another way to think of that is when I open up this big bracket, okay, this negative gets spread out and it changes this to a positive. It makes the bracket negative and then it makes this positive. So that's a little confusing, but that's what a vertical reflection is, or reflection on the x-axis. If you have something like root x and you flip it, and let's say I go ahead and I'm going to add 2 to that in the bracket, so that moves it left 2. And then I will add, so then I'll get out of the bracket and I'll add 7 to that to move it up 7. Maybe that's a bit too much, 6. Move it up 6, and I want to flip it horizontally. I throw a negative in front of this, and it flips it horizontally, a reflection of the y-axis. If I want to make this whole thing negative, I put a negative in front of the whole thing. That will change this bracket or this root sign to be negative, but then I have to change this also. So it's picture a big bracket in front of this whole thing, throw a negative in front of it. Distributive law means change the signs of everything in the bracket, change both of these, and you end up with something like this. And when that happens, the whole graph disappears. No, it doesn't disappear. It's been flipped and it's down here now. Okay, so that is a horizontal flip. Can I flip both ways? Can I flip horizontally and vertically? Sure. I throw a negative in front of the x and I throw a negative in front of the whole function. And that'll flip it horizontally and vertically. Okay, so practice those. And that's it. Okay, reflections, horizontal and vertical. Think of your parabolas and think of what we don't know about parabolas is when the negative is right on the x. Negative on the x, it's a horizontal reflection.